Hi everyone, in this video we're going to go through some of the solutions for the 2020 Methods Exam 1. So Exam 1 being tech-free and no notes. So I'm not going to go through the whole exam. There are other solutions there, but I'm just going to go through questions 6, 7 and 8. And I've already done the solution, so I will circle important things, but they're already there for you. So obviously in a bit more detail than what you would get on an assessor's report. All right, so question 6, we've got a function, so it is a square root graph. So you should be familiar with what your basic graphs look like. So I've kind of sketched one on the side there. So when you think about it, sorry, I shouldn't say when you think about it, but if you do get stuck, just think about what is happening to x. So when x equals 0, f of 0 is 0. When f is 1, it's going to become 1 on root 2. When it's square root of 2, it's going to become 1. And so on. So you can kind of think about it in terms like that and then plot those points and see what is actually happening. For this one here, we're only going from 0 to 2, so that's extremely important. And you can see here, I've also done some points just to help me with my graphing. So we do have 0.00. So when we're thinking about the domain and the range, obviously the domain is given to us, but the range is from 0. And then because our endpoint is x equals 2, we also need to know what the corresponding y value is. So this point here is x equals 1, y equals 2. All right, so that becomes important when we do the domain. So for this question, we need to find the domain and the rule for the inverse. Now remember, your domain of your inverse is equal to the range of your original function. So as I said before, your range, our minimum value is here at 0 and our maximum value is here at 2. And I'm just thinking I must have done, no, I did it around the wrong way. Oh my gosh, sorry, I just wrote that point before around the wrong way and I don't think this is going to, oh, I hate that. There we go. That should have been 2, 1. My bad. Okay, so that is 1. And that's our range. So remember, your range is your y values. And then the domain of your inverse is equal to that. So there's my domain. All right, now getting to your inverse. Now when you're doing your inverse, we do have f of x written here, but there's nothing stopping you from writing y and then x, obviously. Now your inverse, you're switching x and y. So I've done that on the second line. And then we just want to get y equals. And I've just realized, oh my gosh, I've done something that I always say not to do. And that is to write it like that. So that's me actually brushing. So writing the inverse here. All right, you need to use that inverse notation. So that's not really a difficult one. I'm just seeing, yeah, not a difficult one at all to do. All right, so let's move along to graphing it. Now you can see here it's also being graphed for you. So if you couldn't do the domain on the previous question, it's graphed here for you, which is fantastic. Okay, so now we have to graph the inverse. So your inverse, every point switches. Okay, so see how our end point here is 2, 1. So your end point for your inverse is 1, 2. Now the other end point was 0, 0. So obviously the inverse of that is 0, 0. Now the point half, half I've done down here. I've done a table of values. I went probably a bit further than I needed to. So just calculating the inverse and noticing that they're equal here. Oh gosh, why does it do that? Okay, there's so they do cross on the line y equals x. So you don't have to draw this, but I'm just showing you. So it's the mirror image along that line. So they, the point that they intersect at will also always have the same x and y value because they intersect on that line x equals y. I'm just seeing if I did any other working out to work out that point. No, I didn't. All right, so moving along. So this question here, oh my gosh, it took me a while, a few attempts, because I kept making mistakes with my my substitution. Okay, so for this one here, we have to find the total area of the two regions. So one region bounded by the function f and f your inverse, and the other region bounded by f, your inverse, and the line x equals 1. So if we go back here, we're finding the area in here, and then the area, if I just go up here to a line, this area in here. Okay, so we've basically got two regions, and I'm just going to get rid of that because if you sketched additional, actually it doesn't matter. Oh no, we did have to sketch stuff on there, didn't we? I probably should have got rid of that dotted line. Whenever you sketch something, always make sure that if you add anything else, you actually state what it is. So I probably should have written there that that's your inverse. Okay, because I did draw a dotted line on there. All right, let's move on. Okay, so you can see I've separated it into region 1. Okay, so that's that smaller part on the left, and then region 2. So the hardest part for this, or where I kept making my errors, was in my substitution. So we've got our antiderivative, okay, and it's not a hard one to do. So you can see here in our square brackets my antiderivative. I'm just thinking what was the hard part. So we did have to, if you look over to this side here, we did have to substitute in a half. So I did half to the power of 3 on 2. Now, and I didn't really separate it here, but a half to the power of 3 on 2, you can separate it to a half to the power of a half, then to the power of a third. Okay, because your index laws, you're multiplying those powers. So you just separate your unit fraction. So a unit fraction just means the numerator is 1. So we're just separating the unit fraction. So that means we can then take the square root of a half and then we cube it. Oh gosh, no. I did the wrong thing. Actually, no, I didn't. But what I might do, I might put the cubed in here. It's actually easier. So cube 1/2 gives us 1/8 because we're cubing the 1, which is 1, and 2 cubed is 8, and then we can take it to the power of a half. So that's going to be the square root of 1 over the square root of 8, and then the square root of 1 is 1, and the square root of 8, we can simplify that third to root 2. Okay, so that's how I got that. Very, it requires your knowledge of index laws. Okay, I've got 3 dogs here, and they're all tap dancing in the lounge room, and I feel like they're going to start barking. Probably found some possums outside. All right, so I've substituted that in, and you really have to take care. If you want to get the full 4 marks for this question, you really have to take care with your substitution, with working with your square roots, working with your powers, working with your fractions to get the right answer. All right, it is very tedious, but if you're like, yeah, I know how to do this, then just take your time. All right, just take your time. All right, so I end up with 1/12 for that area. The good thing is we then have to substitute in a half again. All right, so we also substituted in 0, which was great because that just means we've got -0 there. But here we're substituting in 1, which I did here, which was pretty straightforward. And then we substitute in a half, which I did here. And I got a 1/12. So I've got 1/12 again. So I didn't have to do that twice. So it's probably good to get it right the first time, although there's no way to check. Yeah. All right, and then we have to add everything together. So your total area, okay, so this is me just simplifying things a little bit. Okay, so your total area, you're adding everything together, and obviously it's asked for it to be in this form. So we want a denominator of 6, and we've got a is a positive integer minus b root b. Okay, so the b's obviously have to be the same number. So 5 minus 2 root 2 over 6. So that means you couldn't leave it as 5 minus root 8 over 6. Okay, because the square root of 8 does have to simplify, as it asks in the question, to 2 root 2. All right, so quite a tricky question, but when you think about it, it is worth 4 marks. So quite a big question. All right, moving on to question 7. I'm just going to take a drink of water. All right, so we've got a function here. It looks like a parabola. And the point P10 is on the graph, so we've got part of, part of it on there. All right, there's no restricted domain, it's just drawn it for us. All right, show the point P is not on the graph. Okay, so it's told us that P is 10. So basically it's saying when x equals 0, f of 0 does not equal 1. No, yes, no, what am I doing? Oh my gosh, this is why I should make videos late at night. When x equals 1, f of 1 does not equal 0. Okay, so we're substituting that point in. So you can see here, oh, excuse me, come on. I've substituted in 1, and it does say that it's equal to 0. So on the left-hand side, I've got 0, and then I'm working out what it actually is. So 0 is clearly not equal to 9. So P is at 10. Whoops. I should have done that around the, oh my gosh. Done that around the other way. Is not at 19, is at 19, not 10. Oh my gosh. A few things I need to fix up, huh? All right, moving on to question B. Consider a point Q. So a f of a, so remember this is just x. So x equals a, and when you substitute that into the function, you get f of a. To be a point on the graph of f, find the slope of the line connecting points P and Q in terms of a. So here's point P, and here's Q. So for Q, I've just substituted it in. Okay, so I've just substituted a in, and this is f of a, just substituted it into that parabola. All right, so we just use, it's looking for the slope, so we just use our formula for the slope, which is y2 minus y1, I was about to write x there, over x2 minus x1. So I've just identified x1, y1 and x2, y2 and substituted them in, and I get this. Now, when I got this answer, I did quickly check whether that a minus 1 on the denominator could cancel something out. So I did quickly check if I could factorize what we have on the numerator to see if it would cancel, and it doesn't. So I could just leave it like that. It is also worth 1 mark, so we don't want to go too crazy with our simplifying. All right, find the slope of the tangent to the graph at f at point Q in terms of a. So the slope of the tangent, well, the slope is the same as your derivative, all right? Your gradient, the derivative is your gradient function. So I found my gradient function, 2x plus 3, and then substituted in a, and I get 2a plus 3. So that's the slope of the tangent. All right, we don't know what a is, so it's just in terms of a. All right, moving along to part 3. Let the tangent to the graph of f at x equal a pass through the point P. Okay, so, oh gosh, excuse me. So again, we're just using the slope formula. So, actually, which we did, I'm just realizing we did here. All right, so remember we found the slope here. So here's the slope, and this is also the slope. So in part 3, all I've done was let the two slopes equal each other, and then I solved for A. So it's quite it's quite a straightforward one, but you do have to be careful with your negatives, and I guess you're cancelling out and just making sure you don't make any small errors or avoidable errors. Okay, so we get A equals 4 and A equals -2. Okay, so not a difficult one. I guess perhaps knowing that you let your two slopes equal each other. Okay, so we've got the slope from, the slope formula, rise over run, and the slope from finding the gradient, and that's helped us find the two values of A. All right, in part 4, give the equation of one of the lines passing through the point P that has a tangent to the graph of F. So substituting in 1, 0. All right, it's a bit hard to understand what I've actually done here. So the tangent is just a straight line. So we've got y equals mx plus c. So that means you need to substitute in x and y. So here we're using point P, x and y, and your gradient. So I've got my gradient function here at this value of A. Okay, so remember we found two values of A. So when I substitute -2 into my gradient function, and you could use either one, but obviously 2a plus 3 is the easier one. Okay, so this, remember, is f dash A. So that's all I've done there. I've just substituted that -2 in and I get -1. So that is my gradient, m. So in y equals mx plus c, y is 0, yeah. M is -1, x is 1, and then we solve for c. So in this case, solving that gives you c. So there's your equation, y equals -x plus 1. Or remember, it says give the equation of one of the lines. So that's fine. You don't have to do the other one, but I just did the other one in case. So we're still using the point P, 1, 0, but this time we're substituting in A equals 4. So when I substitute A equals 4 into, this function, this expression, or our gradient function. Oh, now it's not letting me scroll down. Excuse me. Come on. All right, we get 11. So that's now our value of m, and I get this equation. Okay, so it's two separate equations. All right, question C. And obviously you don't have to do both of them, so you just do one. And I don't think one is easier than the other. Maybe the first one's a little bit easier. All right, question C. Find the value k that gives the shortest possible distance between the graph of the function y equals f(x minus k) and point P. Now, P is this point here. It is an x-intercept. So I'm going to draw this on the graph in a sec. Now, what is happening here? All right, K is shifting. Oh, actually, didn't write that. K is shifting your point, your graph. Shifts graph to the right. Okay, so if we go back to our graph, which is here, we've got the point 0, 1. So that's your point P at 0, 1. Sorry, not 1, 1, 0. And this graph, here's your turning point. So that's going to be the shortest distance between the x-axis and the graph at your turning point. So basically, we need to shift our graph across so that turning point is now directly above P. All right, so the graph moves across so that turning point, because at the moment we've got quite a distance. All right, that's your distance there. So we want the shortest distance, so we want that turning point to be directly above P. All right, scrolling down, 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 down. Okay, which I've just written there. So your turning point is when your gradient is equal to 0. So just solving that, we get x equals -3 on 2. I'm just wondering what it says. Need to move to x equals 1. All right, so basically what we've got currently, what that 3 on 2 is this point here. That's the x coordinate of your turning, or negative 3 on 2, I should say. So this point here needs to go from x equals negative 3 on 2 to 0. So it's shifted 3 on 2 so far. And then we've got to shift it another 1. So plus 1. So 1.5 plus 1 gives you 2.5, or 5 on 2 if we're leaving it as a fraction. So that's what k is equal to. And I've probably written that down. Yes, k equals 5 on 2. All right. Oh, sorry, I probably don't leave things up. But you can pause. You can pause. Okay, question 8. So we're going to stop on this one. See how long it takes. It's 20 minutes. It's pretty good. Question 8. Part of the graph y equals f of x where f is x log base ex, and we're going from 0 to infinity is shown below. The graph of f has a minimum at the point Q, so you can see that here. As shown above, find the coordinates of the point Q. So that is your turning point. Okay, so what we've done here is found the derivative. Now, excuse me, I always do that. Okay, so we've got our function is x times log base ex. So you've got to use the product function. All right, remember the word product means multiply. So we're multiplying one function by another. So we've got x, so you can see I've let u equal x and v equal log base e of x. And then you're just using your product rule. Your product rule is on the formula sheet. So is the derivative of log. So all of this should be pretty straightforward, although it probably appears harder than what it is. Okay, so where is my derivative? Here it is. 1 plus log base e of x. And we're going to let that equal 0 because remember your turning point is when your gradient is equal to 0. So then we just solve for 0 and I get x equals e negative 1, or if you want to write it as a fraction, 1 over e. But because the question is asking for, the coordinates, we also need the y coordinate. So I found x, but then to get y, we just substitute that in and I get negative e to the negative 1. So there's our coordinates there. You do need to write the coordinates to get full marks. All right, now we've got a question that is an example of integration by recognition. Now, integration by recognition we covered in one lesson at the end of last term. We also did it, I also covered it in a video, and I've also done, I think, at least 2 other questions. No, I've done at least 1, maybe even 2 questions when I've done other exam questions. So hopefully you're starting to get familiar because it's not overly difficult, okay? And if you get a question that uses or asks or requires, I won't explicitly say integration by recognition, yeah, it should be quite straightforward for you. Now, it is difficult because it won't explicitly say use integration by recognition, but it will say something along the lines, you know, you're using a derivative or the relationship between a derivative and the original function to show that, or it will say hence to find this. Okay, so what I'm using is this first part. Okay, I've identified my original function, which is x squared log base e of x. Okay, so because this notation, it's saying the derivative of f of x, so this is f of x. So we're used to seeing it as dy dx, but it can also be written as d and then the function written dx, okay, which is what is happening here. So I've identified f of x, and then it's told me that the derivative is this. So that's what I've done underneath. Okay, so your antiderivative of your derivative is equal to, oh gosh, squishing everything in, to your original function. So that's what I've done here. your antiderivative, got my integral sign to show that it's an antiderivative of our derivative. Okay, so done the same thing here. See how they're equal? Is equal to our original function, which is here. Now, I keep that left-hand side as an integral. Okay, I don't do it because it basically wants us to use integration by recognition. So I need to get that left-hand side to look like, so we want the antiderivative of this. So we want it to look like the antiderivative of x times log e of x. At this point, it's not. Okay, we've got this 2 here, and we've also got this x here. So it's just like an algebraic equation where you need to get rid of things. So in what step? Okay, so I went ahead and separated my, separated it into 2 integrals. So there's 1 and 2. And then there's my antiderivative of a half x. And then I put it over to the right hand side by subtracting it, just like you do in an algebraic equation. And what I did here with the 2 is multiplied it by a half, because you could have divided it by 2, but that's the same as multiplying by a half. So that's how the half ended up here and the half ended up here. Okay, because whatever you do to one side, you have to do to the other, or whatever you do to one expression. All right, so I've done it to the first. I had to do it to the second because they're separated by a plus sign. And then I have to do it to the right-hand side. Okay, and then I end up with what I wanted. And it's a show that question. So I do have to just tweak things a little to make sure it looks as like what it looks like there. Now, show that questions, you've got to pretend the answer isn't there. And you've just got to work it until you get the answer at the end. Do not use the answer given to you from the very beginning. Okay, so there's my final answer. And at this point, I would check, okay, does it look like the format that they wanted in? Yes. If the answer was no, first of all, I would check if I actually did it correctly. Can it be transformed into that? It is a 1-mark question. So, you know, I think integration by recognition is quite straightforward, but if you find it difficult, that's 1 mark and your time is better spent doing something else. Okay, let's move on to question C. Find the area of the region that is bounded by F, the line x equals a, and the horizontal axis, blah, 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 where b is the x-intercept of F. Okay, so just trying to think of what I did here. Did we get the graph? Yes, we did. Okay, so I'm just trying to remember what region I want. The area region that is F, x equals a, and the horizontal axis. Okay, so we want, so just this in here. Oh my gosh, I can't even remember. It was, wasn't it? Did I go too far? Line x, yep. Horizontal line F, line x equals a, and the horizontal axis. All right, so we've got to think about what our lower limit and our upper limit are. Now you can see I've got 1 on E to 1, and I've got that negative out the front. So if I just go to my graph, because it's under, actually I haven't done the right, I think I've done the wrong side, haven't I? Is it it's this side? I thought I was doing it wrong. Okay, we want that part there. So A, did we work out A? Oh my gosh, yes. That's 1 on E. Oh, why did I write 6? Okay, and then B, that's what I worked out here. So where is it? So let it equal 0 because just trying to think. Find the area of the region that is bounded by F, the line x equals A, and the horizontal axes. Or okay, x is between A and B. All right, so I found A before, which is 1 on E, and B, this is what I'm doing here. Okay, because B 0 is an x-intercept, so basically we're letting it equal 0. So we get two solutions, x equals 0 and x equals 1. Now, obviously, if I go back up here, all right, there's the first one, and then there's 1. So B is 1. All right, so we're finding the area in there. Because it's below the graph, that's why I've got a negative out the front. You could just switch. Oh, why do I keep writing a 6? You can switch them around, so that's another way of doing it. But you should know that you can't get a negative area. It is asking for the area. So if you got to the end and you got a negative answer, then you might just want to go and think, oh, am I below the axis? Now this one is quite a frustrating one to do. I don't think I made, just looking at it, I don't think I actually made too many errors with this one. It is worth 2 marks. It is not overly difficult knowing your log laws. So log of 1 is 0. Okay, so that gives you 0. What have we got over here? Log base E of E. Yeah, that gives you 1. So that's all right. And I probably took that negative. Yeah, I did. So, oh gosh. Yeah, all the workings there. I'm not going to go through it. But just knowing your log laws. And it's worth 2 marks. So probably getting just 1 mark for writing the correct antiderivative, making sure you got the negative out the front or your lower limit and upper limit are correct. All right, moving on to question D. So what have we got? G of x equals f of x plus k. So the k in this case is a vertical shift. I remember this question being quite difficult, so I'm going to just concentrate. Find the value of k for which y equals 2x is a tangent to the graph of g. Okay, so I've written g of x, found the derivative. Now the gradient of this tangent is 2. So I've let my derivative equal the gradient, which is 2, and then solved for x. So that's what I've written here, m equals 2. That's just come from there. No, sorry, not x equals, I can't remember what I said, x equals e. All right, so we do need to find the value of k. So we're not finding the value of x, we're finding k. So I've got to substitute e back into g of x. So I've got g of e equals e plus k. So this is basically y. And in our equation, we've got y equals 2x. So there's our other y when x equals e. So I'm just letting my left-hand side equal my right-hand side because basically we've got 2 equations. The one they gave us, y equals 2e, and because they the tangent crosses the function at the same point, so at x equals e. So just letting e plus k equal 2e, and that gives us k equals e. All right, quite a tricky question, and it's worth 1 mark. So if you attempted this and you were like, I don't even know where to go, I wouldn't spend too much time on it. It's worth 1 mark. All right, but if you don't get this value of k, then obviously you don't can't really move on to the next one. So I don't think you can anyway. Maybe you could do part of it. So find all the values of k for which the graphs of g and the inverse of g do not intersect. All right, so they intersect at y equals x, like I said before. So if we want them to intersect, so k, remember, is your vertical translation. Just go up here to, actually, what was g of x? I can't even remember. F of x plus k. So k is just shifting this parabola up. So, excuse me. So if we were thinking about the inverse, and I'm terrible at drawing inverses, let's just see whether I can get it. So we've got an x-intercept of 0 and an x-intercept of 1, 0. So that means this one's going to be at 1, and it's going to go kind of like that. So basically they're intersecting here, but as your graph moves up, they're not going to intersect. Okay, so they're going to intersect until you get to a certain point. And this is quite hard to picture on this graph, but I might just say, all right, this is what we've got. Oh God, that's not a very good one. This is what we've got at the moment. And then we've got the inverse of that. Now, if our graph was shifted up, this is not good. All right, so there it's intersecting there. Now, if this graph shifted above, that turning point shifted above that line, then they're not going to be intersecting. The inverse and the original function are not going to be intersecting. All right, so let's have a look. It's a lot easier if I could show you on Desmos, but I guess you can't use your calculator. So, all right, so they intersect at that point at when y equals x, and the gradient of y equals x is 1. So we know that the inverse, what have I written there? 1 plus. So the gradient, is that our gradient function there, is equal to 1. And then we're just solving that. So we get x equals 1. And then substituting 1 into into g of x. So log base e of 1 is 0 plus k. So all right, so we've got k here, but remember they intersect at x, y. So if, and I probably didn't even need to do that. If x equals 1, then obviously y is equal to 1. And actually, no, I did have to do that because I had to get the value of k. So k is equal to 1. That's where they intersect. So basically, anything less than k would bring the graph not high enough. So up until k, they will intersect, but they won't intersect after k is equal to 1. So k has to be greater than 1 for them not to intersect. All right, that's the end. See you later.